Hello, this is Dr. Ele Perumal, corrosion and metallurgical consultant. After a short break, I am starting again my presentations. We will talk about metallurgical behavior of nickel-based alloys. I repeat, nickel-based alloys as considered for chemical process industries in this and subsequent two or three presentations. Nickel is a prominent material of construction for chemical process industries, applications such as heat exchangers, piping, etc. It is considered for applications where carbon steel and stainless steel cannot be used because of their inherent poor resistance to highly corrosive atmospheres. Uh, Nickel-based alloys, there are two groups of nickel-based alloys. One is alloying with chromium, iron, aluminium and titanium. They induce high temperature strength, creep resistance and resistant to high temperature oxidation, uh, where aqueous corrosion does not come into the picture. The next set of alloys are nickel is alloyed with the molybdenum, chromium and tungsten and control the impurities like carbon, sulfur and phosphorus. These give very good resistance to corrosion by highly corrosive reducing acids such as sulfuric, phosphoric and hydrochloric acids, and also with the chloride solutions at elevated temperatures. Uh, but but nickel-based alloys are susceptible, even though they are resistant to atmospheric corrosion, general corrosion, but they are susceptible to localized corrosion such as pitting, under-deposit attack, crevice attack, and stress corrosion cracking. Among these, stress corrosion cracking is the most dangerous form of corrosion, where the other first one, pitting, occurs at a very localized place. Under deposit attack occurs below the deposits, below foreign deposits, and crevice attack is a design oriented attack where if the crevices are formed due to mechanical forming. So these are all unusual conditions. Under this condition, nickel based alloys are susceptible to certain form of corrosion. We will consider only very specific alloys under a nickel series. The Incolloy 800H is a nickel chromium iron alloy. It is developed for withstand high temperatures. And to withstand high temperature and along with high temperature strength, Incolloy HT, high temperature and tensile properties, high tensile properties, modification of the above Incolloy 800H with the addition of aluminium plus titanium to withstand much higher temperatures. And the next two sets of alloys like 2032, that means 20 chromium, 32 nickel, 25 chromium, 35 nickel. These alloys with additions of small amount of niobium and silicon, they are reformer alloys. They are used in cast to form thick sections. Mostly it is used for reformers. The last but not least, the Hestalloy C276, the most common alloy used in chemical process industries, is a nickel, very high molybdenum, a little bit of chromium, a little bit in the sense it will bit more than 304 SS, and small intentional addition of iron. It makes the alloy very good resistant to acidic resistant to corrosion by acids. These are the chemical composition of the alloys I mentioned in the previous slides. The most important to notice is the chromium. I am comparing the element with the common stainless steel, which is called 304 SS, and somewhat higher 316 SS. And these alloys, you can notice that chromium goes up to 23, 22 minimum meter, keeping minimum even a 19 level. And you can see the chromium as compared to 8% nickel in 304 SS. The nickel is much higher. It goes up to 35% in specific alloys. And Hestalloy, it is basically nickel base. And the intentional additions of molybdenum, you can notice in Hestalloy up to 17% molybdenum added, and special additions of iron, and also small amounts of titanium, aluminum, and niobium, which are added at all. At the same time, impurities are very much controlled. Sulfur, lead, and all that, they keep the maximum limits. So these give extremely good corrosion resistant chemical composition, and Hastelloy C276 is the ultimate alloy, whereas these are all have good corrosion resistance, at the same time mechanical properties. Thank you very much for listening to this short presentation. I will follow this up with the specific case studies involving these alloys. Thank you again.